This lesson is going to look at the multiplication and division property of exponents. So let's take a look. If we had 2 squared times 2 cubed, 2 squared means 2 times 2, and 2 cubed means 2 times 2 times 2. And we know that we're going to be multiplying them all together. Well, we know that we still have 2 as our base, but how many 2's do we have? We have 1, 2, 3, 4, 5. So our answer should be 2 to the 5th power. I'm going to do the same for the other 2 examples. 3 to the 4th power times 3 squared. 3 to the 4th power means 3 times 3 times 3 times 3. And then 3 squared is 3 times 3. If we multiply them all together, our base is still 3, but this time we have 1, 2, 3, 4, 5, 6, 3. So our answer is 3 to the 6th power. Now we have 5 squared times 5 squared. 5 squared means 5 times 5. Again, 5 squared means 5 times 5, so we're multiplying them together. Our base stays 5, and how many 5's do we have? 1, 2, 3, 4. So our answer should be 5 to the 4th power. Instead of writing it all out like that, a quicker way to do it is, because we know we kept the base the same, we take our exponents, in this case 2 to the 4th power times 2 to the 3rd power, and we can add them together, because that adding them together would end up counting how many 2's that are there. So we know that this would simplify to be 2 to the 7th power. So our multiplication property, if you're multiplying 2 powers and the bases are the same, you can keep the base and then you add the exponent. And again, up here is a big thing to note. The base does not change. The base stays the same. So if we're taking a look at this, if there's no number written, we can assume the exponents are 1's. So x to the 1st power times x to the 1st power, that gives me x to the 1 plus 1, which is x to the 2nd power, or x squared. Then I have 6 squared times 6 to the 4th power. That gives me 6 to the 2 plus 4 power, which gives me 6 to the 6th power. If I have this one, I have 6 to the 4th power and 6 to the 9th power. I keep my base, which is 6, and then I add 4 and 9, which gives me 6 to the 13th power. And then the last one, I save this one particular because this one's a little tiny bit more complicated, because if you notice, one of the exponents is a variable. I have x to the 5th power times x to the a power. So my base is going to stay the same, but then I have to take my exponents and add them together. So I'd have 5 plus a, and that would be how I would have to leave it, because I don't know what the value of a is, so I could not add the 5 and the a together. So that would be my final simplified answer. So let's take a look at this time. This fraction line means division. So if I'm dividing these, 3 to the 7th power would mean 3 times 3 times 3 times 3 times 3 times 3. That's 1, 2, 3, 4, 5, 6. So one more, times 3. Over 3 to the 3rd power would be 3 times 3 times 3. Now, a time out for a second. If I just had this fraction, 3 over 3, we know that that simplifies to equal 1 whole, right? So I want to take as many of these as I can and turn them into 1's, because I know when I multiply or divide by 1, it doesn't matter, it doesn't change the value. So I'm going to pair up as many of them as I can to make pairs like this that equal 1. So I'm going to pair up this pair, and this pair. So what am I left with? I'm left with my base still 3, but how many are left? I have 4. So my answer should be 3 to the 4th power. If I'm looking at the next one, 5 to the 4th power divided by 5 squared. 5 to the 4th power is 5 times 5 times 5 times 5. And 5 squared, or 5 to the 2nd power, is 5 times 5. Again, I want to make as many pairs of 1's as I can, so that would be a pair of 1, that would be a pair of 1. So my base is still the 5, but how many are left? It should be 2. So my answer would be 5 to the 2nd power, or 5 squared. Now, it may take a very long time to write out all of those numbers in the actual multiplication problem of the exponent. So in order to make it kind of quicker, we have the division property of exponents. The division property is similar to the multiplication property, except you keep the bases the same, but the difference is that instead of adding the exponents, you are subtracting the exponents, because that's what accounts for pairing them up and making those pairs of 1's to figure out how many are left over that are extra. So our division property of exponents, you keep the base the same, but you subtract the exponent. So let's take a look at these. So if I keep my base the same, I have 3 to the 7th power divided by 3 squared. My base stays 3, but then I take my exponents, 7 and 2, and I subtract them. So I would have 3 to the 5th power. And then if I did the 7s, I have 7 to the 6th power divided by 7 to the 4th power. So my base would stay 7, but I would take my exponents and I would subtract them. So 6 minus 4 gives me 7 to the 2nd power. Which I technically could simplify this because this is one of those numbers that's in our list that we have. 7 to the 2nd power is just 49.